I'm going to introduce two people who will be speaking tonight, and they'll be running their presentation for you. The first is Chi from Grey Meta. He's the SVP and Principal Architect at Grey Meta. He's over 28 years of product development experience in the professional television, broadcast, and film industry. He's designed and developed some of the industry's most renowned products used by the largest television networks, studios, and institutions around the world. He was awarded an Emmy Award in 2011 for technology and engineering achievement by the Academy of Television Arts and Sciences, and received the United Kingdom's Queen's Award for innovation and technology in 1997. Chi previously held positions as CTO of Arca Media Technologies, Vice President of Engineering at Front Porch Digital, Chief Technology Officer at SAMA, and Chief Engineer at Snell & Wilcox. We're very, very fortunate to have Chi with us today. Along with Chi presenting will be Renard Jenkins. Renard's here. Thank you, Renard. Renard literally just flew in. His plane landed at 4:45 and raced here through the fun Toronto traffic to get here on time. So thank you, Renard. Renard is the Vice President of PBS Operations, Engineering, and Distribution. Mr. Jenkins has more than 33 years of experience in the television and film industry. In addition to his current responsibilities for the strategic direction and operational management of PBS's entire media supply chain, small little thing, he has also led PBS Advanced Format Center. This is a collaborative venture between PBS member stations, vendors, and manufacturers with the mission of the AFC to explore and develop procedures for the creation, processing, and worldwide distribution of VR and AR, 4K and Ultra HD, high dynamic range content with immersive audio through traditional as well as new and exciting digital distribution platforms. A small task, I think, is what we're all really seeing around here. Mr. Jenkins was recognized with the Innovator of the Year Award in 2017 for his cutting-edge work and accomplishments. Prior to PBS in 2010, Mr. Jenkins held roles at TV One, Discovery, and CNN. Today, Mr. Jenkins serves as a U.S. Eastern Regional Governor of the Society of Motion Picture and Television Engineers, board member of the AMWA, co-chair of the Ultra HD Forum's Interoperability Working Group, a member of the NABA Technical Committee, on the board of directors of the Washington, D.C. chapter of the National Association for Multi-Ethnicity in Communications, a member of the PBS Inclusion and Equity Committee, and was named a SMPTE Fellow in 2018. I'm not sure when he has time to actually do his job, but clearly he does it very well. Please welcome or join me in welcoming both Chi and Renard to speak to us tonight about this little crazy thing called blockchain. Chi, go on up.
Okay. Thank you, Neil. Thank you for SMPTE Toronto for inviting us here to give us a little presentation about blockchains. And welcome and thank you for coming over to spend the time with us today. So my name is Chi. I'm the principal architect at Grey Meta, and we are very involved in the technology of this media entertainment industry, and we provide products to aid the companies in this industry to do some of the most leading edge analysis of metadata and gathering and so on. This talk actually started from a conversation that Renard and I had back at IBC back in September, and it was all about we've got this problem about sort of traceability and how do we authenticate files, and how do we know that a file that gets delivered or gets sent around the world is what it's supposed to be. And we were talking about how does people use these things like blockchains and bitcoins and things? How do people sort of relate to blockchains in our industry? And I don't know if you know much about blockchains, but I'm going to just give you a very brief overview about the technology of blockchains and how we could potentially, and I say potentially, is because we haven't actually implemented this yet, but it's a potential piece of technology that could help this industry validate and verify a whole series of sort of supply and demand and all the different services which are needed in our industry. So this could be a potential key element, a key piece of technology that we could use in the future to aid our services. So I'm not going to go too deep into it. I'm not a sort of super blockchain expert. So this is just a starting slide of what Grey Matter is. We're a very small startup company, only been around for 4 years, but we do help the business, the companies in this industry to provide AI services, and we also do things like QC applications. So you may have all heard about blockchains. You must have all heard about blockchains, But what is it? How does it relate to us? And the only thing we're really interested in is that there is a block of data, and it's really made up of anything that you like. And when I talk about anything, it literally means anything. It could be a piece of text, it could be a bit of some binary information, it could be, a file, it could be a digital certificate, it could be anything that you wish to attach to a piece of information. And this information holds information about date and time, could be dollar values, like Bitcoins would use dollar values, but we wouldn't use specifically dollar values for our purpose, but it would be things like authors, vendors, material, asset numbers, originators. And then the blocks themselves will store information about all the different transactions. A block is actually multiple sets of transactions. It's not just a single transaction, but it could be a multiple set of transactions. So really it's a series of information that can be tagged all together into one big lump of data. And the blocks, as you add each one of these blocks in, it's like imagine a volume of books in a library. You create this volume with multiple sets of different little books and little booklets, and once you've got this volume, you check it into your library, and now that once you've checked it in, it becomes permanently stored. And that record of that block will then stay forever, because what we'll do with that is that we'll mark it, and then we'll stamp it, then we'll checksum it, and all that kind of stuff. So the terminology when you hear about blockchains is really a set of transactions that have formed a block, and from those blocks, when you check it in, it forms a whole sequence of blocks which are then chained together. Now, nothing too magical about it at all. It really isn't that clever, but the way that it's done is that each block, when you check it in, has been checksummed against each other. And if you know anything about things like AES encryption and SSL and so on, you'll find that the sequence of data that you generate the checksums from is irreversible. It cannot be regenerated. If you change the order, if you remove any part of the data, swap it around or anything, if you mess around with any part of that data, the final checksum will not match. So therefore, the guarantee is that when you've checked in these blocks, the checksum guarantees the sequence of events. And that's really the whole crux of what a blockchain is about. So I've sort of jumped the gun a little bit. We have to do perform a transaction. The transaction is verified. Many of these verifications use digital certificates about who the vendors are and so on. It's very similar to web technologies that you may have already played around with. The transactions are stored in a block, which is just literally just a lump of data. The block is given a hash. A hash is the checksum for that content. And then that content is written into what we call a repository, which is really just a database server. Okay. Now, how is this different from any other database? Well, in a blockchain repository, it's a bit like a DNS server. There is really no one location. It's not like it's hosted by just Google or Amazon. It's actually hosted by many different people so that they all bridge off each other and they all tether off each other, and so that when one changes, all of them will all change at the same time. So it guarantees security, and it guarantees that nobody can sort of hack into just one server and modify anything. And of course, the repositories are held by the stakeholders of whatever they're trying to store. Okay? So if we were to provide a blockchain mechanism for, say, this industry, it would make sense, for example, that SMPTE would hold one of the repositories. If Amazon or or IBM or Sony or whoever it is who are interested in this mechanism, each one of those stakeholders would probably want to host a repository as well. But not everybody's going to want to do that because, of course, it costs money. It costs administrative time and effort, and it will have some kind of financial cost involved in running and maintaining a repository. But the whole point of this repository is to be accessible by everybody who wants this information. It sounds all very simple at the moment, So people saying, well, why doesn't there's nothing really that magical about blockchains. It's a very straightforward mechanism of check summing information, putting into a web sort of server, into a database, and so on. But how is that going to affect us? Well, funny enough, in our industry, very few people, very few organizations allow the access of the internet on their networks. Everybody here, from the colleges, university, everybody has free, sort of internet access. But surprisingly, in studios and in all the PBS and people like that, they don't have internet access. They're completely isolated, firewalled, so they don't have it. So how would those type of environments allow blockchains to work? That's a big question, and that could be really a sort of almost a move, a change of methodology within an organization, so that they change their way of working, so that things like this will work. It applies to also things like cloud services. When people move into AWS and so on, you've got to let people have internet access to get to those services. So traditionally, if you're completely firewalled off, how are you going to move to cloud-based content? The distribution of blockchains, registry servers, that's always up for grabs. Everybody will say, well, I want one. My data's on that, and I want to have a share of that. So there's going to be a lot of debate about who holds which servers. And of course the cost involved in maintaining those servers. And it requires cooperative participation. It basically means it's really a thing that is optional. Files and assets and the things that we're dealing with in our media industry, it requires all the people involved to actually cooperate, to put information in and to check it and to verify it. It's not like money where, money can be passed around and has to go through banks and things. We're talking about studios and just, post houses and whatever, or even just applications and vendors. If the vendors don't want to do it, it's not going to work. If the customers, the broadcasters don't want it, it's not going to work. So it's a very cooperative type of system, and it's something that the industry is looking at because there is a need, but the implementation and the actual success of it will depend on the participation of all the interested parties, and it's people like SMPTE who makes the standards and things. In fact, I'm actually involved in many of the SMPTE standards committees, and as part of one of those particular committees, I'm actually trying to start an actual standard for metadata and blockchain use. Right. So what could we use blockchains for our industry? Well, the number one sort of use really is blockchains can provide traceability of an asset. It's really a big, big issue in our industry. Any file, everything now these days that are broadcast that you see around the world comes from a file. You know, tapes are obsolete and so on, but files are now flying around the internet, you know, through sort of just vapor, cloud, everything you want. It's just millions and millions of petabytes of storage and files flying around everywhere. And when you get these files, it's almost virtually impossible to know what's been done to them, where they've come from, who edited it, what version it is, and so on. So we're considering using blockchains to give it some kind of unique identification, literally a fingerprint of what that file is and what it has had been done to it. Okay, so who originated it, who created it, who modified it, who transcoded it, who put in the Spanish soundtrack, who created the Chinese subtitles. Everything that could be done to that file or has been done to that file could be put into this blockchain registry, so that anybody who looks up that registry can find the history of that file. And of course, there's many different sort of uses of it. It's this versioning, for example, just like a version control system, where a file has been modified many times, then you can see the history of that modification. Blockchains can also provide a common method of adding metadata. It's creative metadata. It's information that was not in the original file when it was created. So metadata could be things like AI information. We provide one of the AI services that can recognize people's faces or locations or objects in a file. So what if we were to embed that metadata into this blockchain so that people can search on it? Because then we could say, wow, if you had this information about all the people's faces in this video, you could very quickly just search for those names and find those files that had those people in it. And the metadata doesn't have to be just a piece of text either. It can be any format you like. We can add in, all the things like authors, formats, dates, versions, AI, ML, history, digital certificates, rights management, and all this information into these files, because it's just like an ancillary file, like a sidecar file that goes with the original content. We don't want to put all this information into the content, because that means every time you want to add something, you have to modify a file. And if the files are huge, hundreds, 200 gigabytes each, and you want to add a comment into it, you have to rewrite a 200 gigabyte file just to add a comment into it. And of course, you don't really want to do that. So if you have the flexibility to be able to put and provide any form of metadata into a blockchain and associate and have a very strong link to the file that you're dealing with, whoever then opens up the file and looks up that blockchain will be able to see the history and all the metadata and everything else that goes with that file. Like I said about being cooperative, you can look at it, do something with it if you want. If you don't, ignore it. It's really simple. There is no requirement to do it, but if we all in the industry cooperate, for example, all the vendors, all the creating software, all the things that modify the file, rights to this registry, and all the people who receive those contents look at the registry, then we'll have a really good working system. So now I'm going to hand over to Renard. So he's actually a classic example of actually a user who would want this type of technology. So.
Okay, first I want to thank you all for having me, and it's really, really cool to come and hang out with the SMPTE Toronto crew. Secondly, I want to let Neil know that I do my job by having an incredible team. And over the last couple of years, I've really been able to hire and craft an incredible management core that whenever I am traveling like this, I never have to worry. They will only call me if either they're on fire or if the building is on fire. Other than that, they let me kind of roam. So you heard Chi talk about a few things. He talked about how blockchain can be used, what it actually is. Some of the things that he talked about was security. One of the things that I'm going to talk about is openness. One of the things that he also focused on was what do you do with that structure itself and sort of that block and the way that these things actually attach themselves. So you've got built-in security within that environment. And if you think about it as a platform, which if you've ever heard me speak, I hate the term platform, but blockchain is really a platform. And I hate the word platform because it's limiting. So in this sense, the limitation brings with it security. So the state of where we are right now in the industry, as many of you know, you've got to be everywhere. You've got to be able to deliver content everywhere. The definition of broadcasting has changed. It's no longer an antenna at your home, bringing it down to the rabbit ears on top of your television, and some of you are way too young to know what rabbit ears are, but they existed, and a satellite beaming things around. Before that, it was terrestrial. Now we're in an environment where whatever you have in your pocket or whatever you're using on your watch even, there's data and there's information that's going into it. Now, we don't know where a lot of that data is going, and your mom and dad has probably told you don't believe everything you read on the internet. That's a wise thing to do. So I want to talk about some theoretical cases in which I feel that we can actually use blockchain. And by the way, full disclosure, we are a customer of Gray Meta and have been since their Archimedia days, before they became Gray Meta. And we've been using their products for a number of things. Machine learning is one of the latest things that we're looking at right now. I don't use the term artificial intelligence because I don't believe it exists just yet. I believe that machine learning will lead us there, but I don't believe that artificial intelligence exists just yet. So we're going to talk about 5 things, if we can get through them in time. Automated and secure supply chain processing. Okay, all of us know that our jobs of getting content in and out has to deal with rights. It has to deal with multiple different versions of metadata. Those things actually have to be in a secure environment. What's the worst thing that you can do? And this is a question for the audience. What is the worst thing that you can do if you want to keep clean metadata?
Zip it.
That's a bad thing to do. Yeah. Add humans into the mix. Very simple thing. The more people that you have touching the data, the dirtier it's going to get over time. It is truly like that old game that we used to play as kids, Telephone, where things get worse and worse as it goes through, the group of people. So what does blockchain allow us to do? It allows us to have an environment of a secure state so that you can always know what happened to the data prior to you actually using it or seeing it or actually using machine learning to do something automated with it. So I hope you all can see this. This is what we are building at PBS right now. This is what I call our media supply chain 5.0. 5.0 is because this is the 5th iteration of a media supply chain, and as of a couple of days ago, PBS became 50 years old. So about every 10 to 12 years, they change what they're doing. And I just happened to get there 9 years ago, so I got on the back end of a change, and now I'm on the front end of the next one. And I have no hair, so there's nothing else for me to lose. So as we're looking at what we're doing, I'm going to break this down, and I'm going to show you how blockchain is going to be a part of what it is that we're doing. Okay, so just to have a little fun, if you look, we have a media director and a translator. That translator is the place where we're aggregating APIs. Nobody's doing that yet, but we figured we'd try and figure it out and see what we can come up with. we're talking to a number of vendors who we hope to be able to help us to be able to do that. The code name for that translator is Megalodon. Apex predator, eats everything, spits out whatever it doesn't like, and hopefully what's good comes out the back end, literally out the back end. And the media director, the code name for that, and you'll understand in a moment why, is Meerkat. The idea of the media director is that it is actually going to be looking through everything that goes on throughout this blockchain, this environment, whatever you want to call this thing, but please don't call it a platform, because it's not going to be something that is sitting still. It's not going to be something that is sedentary. It's going to be something that is very flexible. It's going to be moving. All of these things have to actually move around in order for this to work properly. So the meerkat is literally looking around, and if you know anything about meerkats, they signal to each other when there's danger. So the media director is also going to be how we signal when there's danger, and once again, that's going to be another way that we plan on using blockchain. If something comes into the environment that shouldn't be there, the media director is actually going to be able to find that, signal it, and hopefully quarantine it before it actually does any damage to the automated workflows. So let's talk about automated and secure supply chain. So when we kind of break this out and we're just really dealing with the media director itself, if you look farthest over to your right, I think, my left, the cloud-based gateway. Before something comes into the cloud-based gateway, we're putting all of our data into what we're calling a metadata bank. We're not calling it a lake or a warehouse, because we don't want to just kind of sit it there and let it float. We don't want to just house it. We want to be able to make bidirectional informational exchanges. We want to be able to make deposits and withdrawals. So we're calling it a metadata bank. Prior to that, everything has to be tested. It has to be verified. It has to be authenticated. So what's the best way to do that? To use a blockchain. And so when we're using our rights management, or when we're adding from our rights management and we're adding in our traffic information, or we're adding in actually the delivery information for what it is that we're going to do. Remember I said that everything now has to reach everywhere. We want to be able to capture where it's going to go at the front end instead of actually having that take place at the back end. Today, you do that in post. Okay, we know that it's going to be OTT. We know that it's going to be linear. We know that it's going to be, HLS stream for YouTube or someone else. All of that stuff is decided up front, but there's nothing automating it to be created. So if you create a blockchain in which you have all of that information stored in a bank, and then you're actually taking blocks out of that bank, and you're creating various chains to create an automated platform that will actually signal through that middle portion of where we're talking here, all of these things and these microservices can now be automated. That's where you add the human being. Because contrary to some of my peers, I truly believe that the best QC is still a human being. There are certain things that automated QC cannot actually do. It cannot detect creative intent. As you know, we use Ken Burns. He's everywhere on PBS. One of his signature moves is talking over a still, having it move, and fade to black. Now, if you have your automated QC set up to make sure that it's detecting black, which we all should have as a standard, it's going to see that move as a problem. A human being is going to see that move as the Ken Burns effect. Now, that's just one way to actually use some of these automated processes to kind of push things through. But as we're pushing all of this stuff through, what we are now doing is we're embedding metadata within each piece of media. So we have a blockchain. We've created these blocks that are stitching themselves together. We've now created media, which we call, and I should give credit to George Dahlia from Hearst Television. He calls it enhanced media. And the enhanced media is the marriage of media and metadata in which they travel together, and they travel together for the life cycle of that media. So we took what Joe was talking about and we said, okay, let's try and make this real and let's put it into a workflow. And that's what you see in the middle. Those things have to travel with each other. However, we have to make sure that we can authenticate and verify that that metadata that's traveling with that media is what it's supposed to be. Once again, that's where the blockchain comes in. And that's where the media director can actually do its work by being able to validate each one of these moves and each one of these microservices by detecting changes that are not supposed to be there. So the next thing that we are doing is we're creating a token-based federated environment of distributed services. Now that sounds like I just put a bunch of words together just to see what's going to happen, but it's actually not. Blockchains by nature are token-based. You have to have a token in order to make a transaction. So that lives in the blockchain already. So we didn't have to do anything there. Now the fun part happens when we get into the federated environment. And that brings us back to this full-size view of what it is that we're doing. This entire environment itself can be broken out, and each particular part can stand on its own to do multiple functions. Now those functions can be, we're going to signal for it to come in and we're going to do QC. We're going to signal for it to come in and we're actually going to do transcoding. Or we're going to signal for it to come in and we're going to, take baby's first step videos and make grandma really happy. Whatever we choose to do, we start at that front end, but we start once again with the data that's already a part of the blockchain. So that is the way that you start to look at services just in general on a supply chain basis. How many of you know what Kaizen is? Okay, for those of you who don't know, Kaizen is it's a business practice that was started back in the 80s. Well, it really started in the 70s, but it gained prevalence in the 80s by Toyota. And the whole idea of Kaizen is constant improvement. So if you're if you're sort of creating your version of a media supply chain, you don't want to do the same thing that you've been doing over and over again because you're going to get the same result, which is the definition of insanity. That's not what you want to do. You want to continue to grow your processes, and you want it to be essentially a living organism. A living organism, of course, like our bodies, they have to signal to the different parts. Our brain is telling the rest of our body what to do. So for us, we're looking at a blockchain to be able to actually be those molecular cells, but then we're looking at these products such as the media director and the translator to be the brain. And the brain, of course, has to work with the cells tightly in order for this to actually be real. So when you think about this federated environment, think of it in the sense that I have to deliver multiple things from a single object. How am I going to do that simultaneously with a bunch of linear processes? That's not going to happen. And those of you who've been working in broadcast for a long time, you know that we were built on linear processes. Everything went point to point to point, even to the point of satellite being point to point. Uplink, downlink. Terrestrial, box to box. Or in this sense, pop, fiber, pop, box. Linear. If you're talking about a federated environment, nothing has to be linear. I can actually start with content input number 1 and end up down on content output number 9. There's nothing to stop me from doing that except bad data. And bad data is going to say content 1 could end up down on the legacy chain, which we decommissioned, but it still has to be alive because most of us know that we have zombie databases within all of our stations. There's that database that you just can't get rid of because somebody built an Excel spreadsheet filled with pivot tables that no one knows how to undo. So you keep it alive in order to keep getting information out of it. Well, if you don't have good data, you can screw yourself up pretty bad. So that, once again, is one of those things that blockchain actually helps to sort of align. And that's why we're really curious about it, because we're saying if this thing works, and I say if, that's why all of these use cases are theoretical. If this thing works, we can now start all the way back at the contract portion of the supply chain. We can pull metadata out at the contract level, have all of that wrapped up in the media as it comes through the gateway, and all of that information travels with it. So if a producer is supposed to deliver something to you on day 1 of 2020, and they say, well, the contract says X, you don't even have to go back to the contract. You can simply take a look at the header of the media and say, no, you were supposed to deliver it day 1. For me, what that does is that takes my entire gateway department, which spends a lot of time right now on the phone talking to producers and telling them that, yes, you have to pay that fine. That gets them out of that picture, because you can send an automated message back to say you didn't deliver on time. Here's how much will be either taken from your cost, or how much you'll have to deliver. So you make it very, very simplistic in the sense that you are now removing humans out of the areas where it's really a headache for them to be there, and you're putting them in the places where they're most useful and where they're most efficient. So automated secure metadata verification, we kind of talked a lot about that, so I'm not going to spend too much time on it. She talked about what blockchain does in order to do all of those things. And there's 3 different versions. There's a public blockchain, a private blockchain, and of course everybody has a hybrid. Now, I would stay away from hybrid right now, and to be honest, I would stay away from open. Open blockchain right now is truly open, which means that anyone can get in and anyone can add to the chain. Now, while they may not actually touch any of the legacy blocks, they could add in a block that causes what's known as a hard fork. And what that is that you've created an area in which a blockchain has to come to a point, and it's sort of like, the blues, where you have, the good side and the evil side, and you got to figure out which way you're going to go, and, Satan's there giving you a deal so you can go down the wrong road and play the blues and, the whole thing. If you guys don't know about that, that's sort of an American thing. Watch a couple of blues movies, you'll love it. So it's basically the Crossroads. So if all of you know Eric Clapton, he does the Crossroads Festival. That's what it's all about. That's what Crossroads means. And it's an old theater. So when we talk about what we're actually going to do in this area of metadata and how we're going to verify it, once again, like what Chi was talking about, that's where blockchain really, really thrives. It creates an environment that can't be toyed with. At least it can't be toyed with without individuals recognizing that something has changed. We'll talk in a second about deep fakes and why it's very important for blockchain to be a part of sort of this content fabric, as Michelle Munson calls it. And if those of you who don't know who Michelle Munson is, I want you to look her up. She won one of the most prestigious SMPTE awards this year for her work, her previous work. She was the co-creator of Vespera, which all of us use to send things back and forth. Her and her husband are a dynamic team. They are at the front end of what blockchain can do. And I mention them because we're using their company, Illuvio, along with Great Meta, to actually help create for us a way to get through 50 years of archival material, to create rich metadata within that space, and to actually use machine learning to create an actual true blockchain content fabric in which authentication, verification, and token will actually be the way that we can actually push a lot of these automated processes forward. So speaking of that, one of the things that we're looking at doing is a dynamic channel creation. We're not going to get to that yet. I'm going to back up here. So that was a pretty scary picture. You'll see why in a second. I'm not going to say anything bad because this is going to go on YouTube, but yeah, that was horrifying. So dynamic channel creation. How many of you work in broadcast who are here? How many of you work in broadcast? How many of you have worked in master control? Okay. How many of you are engineers? Okay. How many of you are asked to work in master control? Okay. That should have been everybody, because at some point in your career, you're going to go to master control, because that's just what has to happen. That's the last stop before everything gets out. So the thing about it is we've talked about all these theories of how we can actually create this flexible environment to do all these wonderful things. Well, one of the things that you have to do is you got to create a channel, and you got to be able to get that channel out to everyone else. Today, traditionally, you have a traffic system. People are putting data into the traffic system. There's a programming person who says, I think that this particular piece goes very well here, and it's going to generate the biggest audience. But in the world that we're in today, people kind of like the a la carte mode. They like to choose what they want to choose. That's why DVRs became such a big thing, and that's why YouTube TV and Hulu and Sling and all these things have become really, really exciting to people, because you get to kind of program your schedule for you. Well, what if we had a content fabric that was built on blockchain, in which you had, say, a cache of tokens that you can use to actually say, I want to program my own channel. And when I program my own channel, the way that the system is set up, it will only charge you for what you actually use. Now, if there are any cable providers in here, I'm very, very sorry about what I'm saying, because this destroys your model. However, think about saying, I want to watch Charlie Brown Christmas, and then I want to watch, A Christmas Story, and then I want to watch, It's a Wonderful Life. And all of these things are here for you to be able to choose them. And you go in, you use your tokens, you actually do that. However, the person who owns the rights to all of those pieces, they have to get paid some way. Well, now you have this transaction that took place, your money is gone, but the platform in which it is sitting will now have to pay to the rights owner. Well, that whole transaction can take place in a blockchain fabric, and it doesn't have to ever touch some of the traditional things that we do today. So it kind of blows your mind in the thoughts of like an ERP system being a part of something like this, where it's just sitting in the background generating all of these messages, just constantly generating all of these messages. And the tokens are flying around freely throughout this entire thing. So that's another thing that we are looking at right now is we just started actually streaming PBS on YouTube. And by doing that, the first step is to get out the door and kind of get it out there. But eventually people are going to kind of want their DVR in the sky. And so how do we do that in a way that's not going to destroy our infrastructure and cost us a lot of money to kind of have to spin up all of these different things to deal with all these different channels? By creating a dynamic channel creation environment in which people can simply pull and push as they need to, you can get beyond sort of the traditional linear hardware boxes and all that kind of stuff in your particular plan, which has all kinds of other financial benefits along with it, such as you don't need to have as big of a generator or as big as HVAC and all these other things that can now take a back seat to actually allowing you to create channels and to do the fun stuff, which is why we all got in this business in the first place. So now let's talk about content authentication, deepfakes. Everybody has heard about this. Everybody is aware that this is a probability right now. And the technology is getting really good to the point where some of these things cannot actually be detected by the human eye. We were at HPA last year, and they actually created a version of Tony Robbins, the motivational speaker, and they had him saying all kinds of things because they had recorded his voice over time and then edited it into different things. But they created his face through a 3D application and mapped it to his lips. Freaky. I mean, granted, I was motivated by the time I left because he's good at what he does, but it was really freaky to see that they were creating this on stage. So it's pretty scary stuff. So let me see if I can hit play on this thing. And we're gonna just take a couple of minutes here. Let's see if we can get this to play for us. Okay, this was a video from the PBS website about deepfakes, and it was done by one of our programs, Nova. So I just want to show this to you.
Help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates good new jobs. You see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele.
It's sort of learning to recreate that person's face by looking at the thousands of images over and over and over. Like a lot more research than you would think would go into making a goofy video or something like that.
Truly surprising for me. Yeah, I was just really surprised.
I didn't do any after touching on that video. That was just using the technology that was available from the machine learning side.
You don't even have to know what GitHub is. You don't have to know how to program in Python. None of that matters. You pay somebody $20 and they'll create the fake for you. That's a bit of a game changer.
You know, the everyday person who the deep fake sex video emerges in a Google search of your name, where for that person, it becomes almost impossible to debunk.
While I don't think that's likely, I also don't think it's out of the question. And that is enough to keep me up at night. The margins are very, very thin. The last national election here in the US was 80,000 votes in 3 states. You don't have to fool tens of millions of people.
I don't think the deepfake will become a big political issue during the course of the campaign. Think about a well-placed rumor before an IPO. I think a lot of these things were problems already. And so it's unclear to me how much machine learning really, adds to those problems. I find it very difficult to sort of believe that there is something so uniquely devastating about video.
Right now, what we are focusing on is developing forensic techniques to protect world leaders from deepfakes. We are particularly worried about how the Donald Trumps, Theresa May, and Angela Merkel's of the world, how their likeness will be used to disrupt elections and incite potential violence in countries by creating fake content. There's some fun and entertaining and interesting application, but there is a weaponization of the technology. And I simply advocate that we as technologists, we acknowledge it, and we start thinking not after the fact, but before the fact, how can we start putting some safeguards in place?
So as you take a look at that, that's got to be scary. The idea that someone could take your face, imitate your voice, and create something totally different than maybe what you would have said. If we, as an industry, decided to go down the road of creating a content fabric on which we had authentication for every single piece of media that was entered into the space, we will be able to easily identify when something is fake. Now, PBS is considered to be one of the most trusted organizations in the world. We have numerous news programs. A product of this type could be extremely beneficial for us to be able to make sure that we continue to deliver facts and facts only. So once again, for me, it's the practicality of what the blockchain has to offer through its inherent security and through its inherent ability to verify and authenticate media and assets and whatever else, as she said, you choose to put into the block. So with that, I'll say thank you very much. I appreciate you being such a good audience, and I hope to see you all maybe in October at the SMPTE Technical Committee.